Example 3. Car A is traveling west at 50 miles per hour. Car B is traveling north at 60 miles per hour. So car A is the green car, it's heading west. Car B is the purple car, it's heading north. Okay, and both are headed in for the intersection of the two roads. Question: at what rate are the cars approaching each other when car A is 0.3 of a mile and car B is 0.4 of a mile from the intersection? So that means the distance between them with this line would be your z. This line is x, this is y, then this is z. So the question is, what is dz by dt? Given that dx by dt is 50 miles per hour, dy by dt is 60 miles per hour. So let's go ahead and start working this out. So let's continue. So let x be the distance of the car from the intersection. Let y be the distance of car B. So that's car A, car B. Then we're going to create a right triangle. So there's your z. So what's given would be dx by dt, which is equal to negative 50 miles per hour. Why it's negative? Because the distance from A to the intersection is decreasing. Okay, dy by dt is given as negative 60 miles per hour. Again, with the same situation, the distance of car B is decreasing from the intersection. And so the question is, we are to find dz by dt. Okay, at the instant when x is 0.3 and when y is 0.4, right? Okay, so as we were working on it, let's continue. So now we use the equation. So we use the equation x squared plus y squared is equal to z squared. Okay, then remember z is changing. So here is your x, y, and z. So differentiating each term by term with respect to time, you go 2x times dx by dt, chain rule, 2y times dy by dt. The derivative of z squared with respect to c is 2z, then multiplied by the derivative of z with respect to time. Okay, so now everything is to solve for dz by dt, we divide everything by 2z. So divide everything by 2z, 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 that cancels out the 2's. Okay, so now we see that dz is equal to y over z, dy by dt, plus x over z, dx by dt. Now, do we know all the information now? Can we solve for dz by dt? This is given. That's given. That's given. We know what this is. So now we have to look for z. Okay? So since this is we can still use the Pythagorean theorem to solve for z. So z is equal to the square root, because remember z squared is, but since we're looking for the length of z, of x squared plus y squared, so that's going to be the square root of 0.3 squared and then 0.4 squared, and when you work that out, that's going to be equal to 0.5. So now we've gotten all the information, so it's time to plug in everything. So now dz by dt is equal to, that's going to be 0.4 over 0.5, and that's negative 60 miles per hour. And then this is 0.3 over 0.5 times negative 50 miles per hour. Okay, and when you simplify all that, everything when this works out, it's going to be negative 78 miles per hour. Please make sure you check those. So that's the answer for how fast these two cars are approaching each other. Okay, so that's equal to minus 78 miles per hour. Okay. Next problem. Right. If A is the area of the circle, so we've got your circle. We've got a circle, and the area, it has a radius r. Right, so there's your radius r. So area is A. And then the circle expands as time passes. It says find dA by dt in terms of dr by dt. So obviously the equation that we're going to use is pi r squared. And all you have to do is differentiate both sides with respect to time. So dA by dt would be bring down to 2 pi r. And then that's just the derivative with respect to r. So now multiply by dr by dt. And that's it. That's all it says. It says is find dA by dt in terms of dr by dt. Okay? So now let's relate this problem to an oil spill. So, okay, suppose oil spills from a ruptured tanker and spreads in a circular pattern. Okay, so if the radius of the oil spill increases at a constant rate of 1 meter per second, how fast is the area of the spill increasing when the radius is 30 meters? Okay, so really it's just an application of what we've already gotten here. So that means dA by dt, is what we're looking for, would be equal to 2 pi times, right, so let's see. It says here that the radius increases at a constant rate. So what does that tell us? That means dr by dt is 1 meter per second. So, and then it says how fast is the rate, or how fast is the area increasing when. So that's the instantaneous. So that's what you multiply r, that's what you substitute r for. So r here that we will substitute would be 30, and then 1 times 1. And notice that if we look at this, that's going to be 60 pi. Now what is the unit of measure? This is going to be meters, and then meters per second, so it's going to be meters squared per second. So that answers the question of how fast the area of the spill increasing when the radius is 30 meters. Okay.